A very good evening to all of you. Today we are going to discuss GATE 2018 question paper. Myself, Dr. Abhishek Tiwari, and today we are going to discuss GATE 2018 Metallurgical Engineering question paper. So, question number one. This is just an English question. So, when she fell down the stairs, she received many stairs but little help. So, the correct answer is A. In spite of question number two, in spite of being warned repeatedly, he failed to correct his out of these questions errant behavior. So question number two, correct answer is C. Now question number three, sin x and cos x both are decreasing functions in interval. So this is the red curve is for sin x and the uh, blue curve is for cos x. So sin x is decreasing in the interval pi by 2 and 3 pi by 2, and cos x is decreasing in the interval 0 and pi. So the common interval is pi by 2 to pi. So the correct answer is B. Now question number 4. So area of equilateral triangle is root 3. What is the perimeter? So root 3 a square by 4 is equal to root 3. So a square is equal to 4, a is equal to 2. So the perimeter is 3a. So this will be equal to 6. So correct answer is C. Arrange the following three-dimensional objects in descending order of their volumes. So the volume of cuboid is A into B into C. This will be equal to 480. And volume of cube is A cube is 8 cube. This will be equal to 512. Volume of cylinder is pi s square h. This will be equal to 1078 centimeter cube. And volume of a sphere is pi 4 by 3 pi r cube. This will be equal to 1437 centimeter cube. So the correct order is option D. Now, an automobile travels from city A to B and returns to city A by same route. The speed of the vehicle during the onward and return journey from were constant at 60 km per hour and 90 km per hour respectively. What is the average speed in kilometer per hour for entire journey? So A to B distance is x, B to A distance is x, and the time taken will be distance upon velocity x upon 60, and B to A distance upon velocity x upon 90. So average speed from A to B to A, this will be total distance is 2x and total time taken is x upon 60 plus x upon 90. On solving we get 72 km per hour. So correct answer is A. Now we have a set of four parallel lines intersect with another set of five parallel lines. How many parallelograms can be formed? So number of parallelograms. So first we have to select four lines to make one parallelogram. So we need to select four lines. So out of these four lines, one line can be selected in four ways, and the next line can be selected in three ways. And out of these five lines, first line can be selected in five ways, and the next line can be selected in four ways. So these are the number of ways by which we can select the lines, and divided by 4 because 4 lines make one parallelogram. So this will be equal to, the correct answer will be equal to 60. So correct answer is C. Now question number 8. To pass a test, a candidate needs to answer at least 2 out of 3 questions correctly. A total of 6 lakhs 30,000 candidates appeared for the test. Question A was correctly answered by 3,30,000 candidates. So NA is given 3,30,000. Question B was answered correctly by 2,50,000 candidates. So NB is 2,50,000. And question C was correctly answered by 2,60,000 candidates. So NC is 2,60,000. And both A and B were answered correctly by 1 lakh candidates. So N A intersection B is 1 lakh, and both B and C were answered correctly by 90,000 candidates. So N B intersection C is 90,000, and both A and C were answered correctly by 80,000 candidates. So N C intersection is 80,000. Now N A intersection B intersection C. Uh, in this question, it's given that if the number of students answering all questions means N intersection A intersection B will be equal to is same as the number of answering none. So number of answering none will be equal to 6,90,000 minus n A union B union C. So this is like n A union B union C uh, represents the set in which a student answer at least one question. So 6,30,000 minus n A union B union C is the number of student answering none. Okay. So now we apply the formula, and A union B union C will be equal to NA plus NB plus NC minus NA intersection B minus NB intersection C minus NC intersection A plus NA intersection B intersection C. By putting the values, we get this, and then A union B union C, this will be equal to 5,70,000 plus NA intersection B intersection C on solving this our equation, and NA intersection B intersection C, this will be equal to 6,30,000. We have put this value on this. So 6,30,000 minus 5,70,000 minus n intersection B intersection C. On solving this, we get n intersection B intersection C to be 30,000. So this is n intersection B intersection C is 30,000, and we calculate the relevant values from this. So in the Venn diagram, we have to calculate how many candidates fell. So the candidates fell if they answered only one question, or they answered none. So this is 1,80,000 plus 90,000 plus 120,000 plus 30,000. So this comes out to be 4,20,000. So the correct answer is option D. Now question number 9. If x square plus x minus 1 is equal to 0, what is the value of x raised to 4 plus 1 upon x raised to 4? So x square plus x minus 1 is equal to 0. Divide this whole equation by x, because x is non-zero. So x plus 1 minus 1 upon x is equal to 0. On squaring both sides, we get, we rearrange this equation, x minus 1 upon x is equal to minus 1. Square both sides, we get x square plus 1 upon x square minus 2 is equal to 1. So we get x square plus 1 upon x square is equal to 3. Then again we square this, and this. So x raised to 4 plus 1 upon x raised to 4 will be equal to 7. So the correct answer is C. Now question number 10. In a detailed study of annual crowbars in India, it was found that there was relatively no growth during period 2002 to 2004. A sudden spike from 2004 to 2005. In another unrelated study, it was found that the revenue from cracker sale in India, which remained fairly flat from 2002 to 2004, saw a sudden spike in 2005 before declining again in 2006. The solid line in the graph below refers to annual sale of crackers, and the dashed line refers to the annual crowbars in India. Choose the most appropriate inference from the above data. So in this, these two graphs are closely related. So there is a strong correlation between crowbars and cracker sales. So correct option is A. For a laminar flow of a liquid metal over a flat plate, the thickness of the velocity and thermal boundary layers are delta V and delta T respectively. The kinematic viscosity is viscosity upon density of liquid metal is significantly lower than its thermal diffusivity. Based on this information, pick the correct option. Delta V and delta T relation we have to identify. So first we need to know about the laminar flow. Laminar flow is characterized by fluid particles flowing smooth paths in layers, and with each layer moving smoothly past the adjacent layer with little or no mixing, and the fluid tends to flow without lateral mixing at low velocities, and adjacent layers slide past one another like playing cards. Now this is for laminar flow, and this is for turbulent flow. So this is the boundary layer thickness, and this is the velocity profile. So, and Reynolds number is rho ux upon mu, and this can be written as ux upon mu, where re is the Reynolds number, u is the free stream velocity, and x is the distance from the leading edge, and mu is the viscosity, and mu is the kinematic viscosity, that is mu upon rho. Again, for laminar flow, we can write delta upon x is equal to 5 upon under root of Reynolds number. So, and this is for Reynolds number less than 5 into 10 to the 5. And this boundary layer we define at y is equal to delta, where u is equal to 0.99 u, and where capital U is the free stream velocity. Okay, and so this is, let's say, this is the velocity boundary layer, and this is the thermal boundary layer. This can be above or below depending upon the situation. And similarly, this is for the thermal boundary layer. So this is the temperature profile uh, for thermal boundary layer. And similar concepts exist for velocity boundary layer and for thermal boundary layer. So now actually this question can be solved by having relation of delta T and delta V. How? Because Prandtl number is nu upon alpha, that is the kinematic viscosity upon thermal diffusivity, that is mu upon rho upon K upon Cp rho, that is Cp mu upon K. Okay. Now this is for the thermal boundary layer. Let's say this is delta T and this is delta V. And if in the question given kinematic viscosity is lower than the thermal diffusivity, that means the Prandtl number is less than 1. Now here from this relation we get delta upon x is equal to 5 upon under root rex. If we rewrite it as, we can rewrite it as delta t is equal to delta v Prandtl number raised to power minus 1 by 3. So this can be written as delta t is equal to 5 under root of mu x upon u0 Prandtl number raised to power minus 1 by 3. So delta v by delta t will be equal to Prandtl number raised to power 1 by 3. If Prandtl number is less than 1, then Prandtl number raised to power 1 by 3 is less than 1. This means delta v upon delta t is less than 1. This means delta v is less than delta t. So the correct answer here is option A. So this means heat diffuses very quickly in liquid metals for Prandtl number less than 1. Now question number 2. What is the most abundant anion in a 2CaO SiO2 melt? So the correct answer is option A, SiO4 4 minus. This is a pretty straightforward question on Buckingham Pi theorem. We have 5 independent variables, and these are represented in 3 dimensions, M, L, T. So according to Buckingham Pi theorem, if we have a physically meaningful equation f q1 q2 qn is equal to 0, where qi is are the n independent physical variables and they are expressed in terms of k independent physical units, then the above equation can be restated as f as a function of pi 1, pi 2, and pi p is equal to 0, where pi I are the dimensionless parameters constructed from qi by p is equal to n minus k dimensionless equations called as pi groups. So n minus k, that is 5 minus 3 is equal to 2 independent dimensionless variables are required to restate this equation. So, okay, so the correct answer is option A. Question number 4. In a fourth flotation process, the primary purpose of adding collectors is to make the surface of mineral hydrophobic. So the correct answer is option A. So these are some terms that are very important to know about the froth flotation. So froth flotation is a process for selectively separating hydrophobic materials from hydrophilic, and this is used in mineral processing, paper recycling, and wastewater treatment industries. And froth flotation was first used in mining industry. And these are other terms that I'm not going, but on these also questions are asked in gate examination. Question number 5. Arrange the following in the correct sequence of operation in an integrated plant. So the correct answer is, first we go to the blast furnace, and then basic oxygen furnace, then ladle furnace, and then vacuum degassing. So the correct option is D. So this blast furnace we have discussed already in earlier lectures, and this is just to briefly reproduce about blast furnace. So, and this is for a basic oxygen furnace. This is also we have discussed already in detail. And this is a ladle furnace. So, ladle defining furnaces are used to raise the temperature and adjust chemical composition of molten metal. Without a ladle furnace, higher tape temperatures are normally required for steel making furnaces due to heat losses during refining with conventional ladles. And this is the vacuum degassing. So this is the typical vacuum degassing process. So during the steel making process, while the molten steel is still in lead and before it is poured, the steel must be degassed in order to reduce, eliminate dissolved gases, especially hydrogen and nitrogen, and reduce dissolved carbon to improve ductility and to promote preferential oxidation of dissolved carbon over chromium when refining stainless steel grades. So this is question number 6. During decarbonization in steel bath at 1550 degrees centigrade, the composites of dissolved carbon, weight percent carbon, and the dissolved oxygen, weight percent oxygen, follows this relation. Weight percent of carbon into weight percent of oxygen is equal to K, when partial pressure of CO, PCO, is 1 atmosphere and K is equal to 0.002. PCO is equal to zero point 0.1 atmosphere. What is the value of K at the same temperature? Note, assume Henry's law is applicable. So for a dilute solution, the concentration of solute is approximately proportional to its mole fraction. That is, Henry's law can be written as P is equal to Kh into X. Henry's law is a gas law that states that the amount of dissolved gas in a liquid is proportional to its partial pressure above the liquid. And since we are decarbonizing, so here is the important point, that we are decarbonizing. So actually, CO is going out. So the proportionality factor is the Henry law constant. So C plus O giving you CO as the equation, and according to Henry law, PCO should be equal to K into CO. Okay, but this CO is going in decarbonization. So this can be written as K into C into O. So this can be written as K into weight percent of C plus weight percent of O. Now, so this is something similar to this equation. So when PCO is equal to 1 atmosphere, so PCO will be equal to, from here, PCO equal to K into weight percent of C plus weight percent of O. So this will be equal to, PCO is 1 is equal to, K is given here, K is given here 0.002 into weight percent of C into weight percent of O. And when PCO is equal to 0.1 atmosphere, so PCO is equal to K into weight percent of C and weight percent of O. So this will be equal to 0.1 into K into weight percent of C and weight percent of O. So K comes out to be 0.002. Okay, so this we can calculate. Now, during the offset forging and considering friction, which of the following profiles represents the axial compressive stresses? So, for forging pressure, P is equal to minus 2 mu upon S into X plus C. So, in this, the option A is correct, because for X greater than 0, this is decreasing, and for X less than 0, this is like increasing. So, correct answer is A. Now, question number 8. Consider the following engineering component: gas turbine plates, tungsten-based heavy alloy penetrators, and self-lubricating bearings, and engine block of an automobile. So, gas turbine blades corresponds to investment casting or lost waste processing, and tungsten-based heavy alloy penetrators are made by powder metallurgy, and self-lubricating bearings are also made by powder metallurgy, and engine block of an automobile is made by casting. So by powder metallurgy, actually Q and R. So are made. So the correct option is B. Which of the following materials are protected by passivation? That means formation of a thin adherent film on the surface from corrosion. So in this, the correct answer is like aluminum or mild steel or stainless steel or silver. So what is the correct answer out of this? So aluminum makes passive film Al2O3, and stainless steel also has chromium, so Cr2O3 passive film. So P and R are the correct option. So P and R, that means option D is the correct option answer. Question number 10. The CYA ratio of ZnSCP is 1.856. Slip at room temperature occurs most easily on which of the following slip systems in Zn? So these are the options, and out of this, actually in SCP metals, the idea is CYA ratio is 1.633. So these are the typical slip systems available for SCP, and lower than ideal CYA ratio promotes non-basal pyramidal C plus A slip system, and higher than ideal CYA promotes basal slip system. So in this, actually CYA is 1.856. That means it will promote basal slip system. Okay. Now this can be represented as in a graph also, like for CYA ratio in this for CYA ratio above 1.633, it will promote the basal plane, and for below uh, 1.633, it will promote this prismatic plane. Okay, so in this actually the correct answer is option C, that is 001, 11, 2 are 0. So this is the basal slip plane, because for above 1.633, this basal plane favors. Okay, so option C is correct. Question number 11. At equilibrium, maximum number of phases in a three-component system at constant pressure is. So it's a simple Gibbs phase rule. F is equal to C minus P plus 2. Three-component system is given, so C is equal to 3. We are operating at constant pressure, so this will be equal to 1. So here F is equal to C minus P plus 1, so 3 minus P plus 1, so this F is equal to 4 minus P. So maximum number of phases presents are, so because no, maximum number of phases, so P is equal to 4 minus F, so maximum number of phases presents are 4. The correct answer is option D. Question number 12. For a single phase system with k components, exact differential of gas free energy is dg is equal to minus s dt plus vdp plus sigma mu I dni. Which one of the following can be derived from the above expression as a Maxwell's relation? So dz is equal to, if dz is equal to m dx plus n dy, then derivative of m with respect to y at constant x will be equal to derivative of n with respect to x at constant y. Similarly, so if we apply this to this equation, we get derivative of s with respect to p, and at a constant at constant t, sorry, for x we have to write t, okay, is equal to minus dv upon tx into y. So this option A is correct. Now question number 13. For intrinsic Si at room temperature, the electron concentration is equal to hole concentration is equal to 1 into 10 is to 16 per meter cube, and the electron and hole mobilities are 0.1 and 0.2 meter square per volt per second respectively. What is the room temperature electrical conductivity? The charge of an electron is 1.6 into 10 raised to power minus 19 coulomb. So sigma electrical conductivity is equal to mu e E plus mu h EH into Ni, where E for electron and H for hole. So EH is equal to 1.6 into 10 raised to power minus 19 coulomb, and Ni is electron concentration and is equal to hole concentration. This is given as this, and mu E mu H is, we put the values and get sigma is equal to 4.8 into 10 raised to power minus 4. So correct answer is option D. Question number 14. To minimize refractory loss during BOF steel making, slag is supersaturated with which of the following? So Al2O3, Fe2O3, SiO2, MgO. The BOF steel making is known as basic because fluxes of burnt lime or dolomite, which of the chemical bases are added to promote the removal of impurities and protect the lining of the converter. Therefore, slag is supersaturated with the basic oxide MgO. Which of the following welding process is not suitable for joining thin metal sheets? So this is about different types of welding. So electroslag welding is not suitable for joining thin metal sheets. So first, we also discussed a little bit about welding. So gas metal arc welding. Gas metal arc welding is also known as metal inert gas (MIG) or metal active gas (MAG) welding in Europe. The term semi-automatic or CO2 welding are sometimes used but are less acceptable, and GMW uses heat generated by an electric arc to fuse the joint area. The arc is formed between the tip of a consumable continuously fed filler wire and workpiece, and the entire arc area is shielded by an inert gas. So this is the typical setup for GM&W. This is the filler wire. This is point active gas nozzle, shielding gas, material transfer, weld pool, workpiece. Now these are some salient features of GM&W. So generally the wire is between 0.6 and 2 mm diameter, and the inert gas can be argon or helium with addition of oxygen, CO2 or other gases. Some salient features of GMW are it has a low heat input, continuous operation, high deposition rate, no heavy slag, reduced post weld cleaning, low hydrogen, reduced risk of cold cracking, and depending upon the operation mode of the process, it may be used at low currents for thin sheets. And the question is asked, which cannot be used for thin sheets. So this can be used for thin sheets, okay, and for positional welding. So these are some salient features of this. Some more information. I'm going to skip this. Now, ESW. So this is also very important. This is the typical setup. So electroslag welding utilizes the heat generated by the electrical resistance heating of molten slag bath to melt both parent material and the continuously fed filler wire. The process is normally carried out with the joint axis vertical and water-cooled copper. Screws are used to retain the molten slag and the weld cool prior to solidification. So the process features are high heat input, high productivity, sections may be welded vertically, and limitations are thermal damage in HAZ, need to weld in vertical position, minimum thickness around 25 mm. So this is the point they have asked in that can it be used for thin plates? No. So electroslag uh, welding cannot be used for thin plates because the minimum thickness required is 25 mm. This is typically for EVW. This is the setup. A beam of electron may be accelerated by a high voltage to provide a high energy heat source for welding. The power density of electron beam is high, 10 is to 10 to 10 is to 12 watt per meter square. So these are the typical features. You can go through these for details. It has high energy density, localized heat source, high depth to width ratio. Normally requires vacuum and high equipment cost is there. And this is laser beam welding. So we have sealing gas, powder nozzle, laser head, laser sealing gas, powder is there. And this is the typical weld area. This is plate A and plate B are joined using laser beam welding. This is typical details about laser beam welding. So it is high energy densities, confined a heat source and lower power than EVW, and reduced distortion and thermal damage, and no vacuum is required in this, and high equipment cost is there. Now question number 16. Which of the following categories of materials is suitable as a filler for brazing of steel? Sorry. So brazing and soldering use a filler material which has a lower melting point than parent material to form a joint. For structural applications, both methods require a lap or capillary type joint design. Filler materials with melting point below 500 degrees centigrade are normally used for soldering, while material which melt at temperatures below temperatures between 500 degrees centigrade and melting point of parent material are used for brazing. The temperature resistance of such joints is limited by melting point of the filler, and the mechanical strength is a function of interface area. The solidification temperature of filler materials should be nearly equal to solidification temperature of the steel sheets to avoid stress concentration. So the correct answer here is near eutectoid alloys. For others, actually, like for epoxy resin, the melting point is uh, not comparable to steel. It's very less, like I think 350 or so. Now, question number 17. Arrange the following processes in increasing magnitude of surface roughness of casting. The first is investment casting, permanent mold casting, pressure die casting, and sand casting. So, increasing order of roughness is pressure die casting, then investment casting, then permanent mold casting, and then sand casting. So, this is the typical investment casting procedure. So investment casting is manufacturing process for metal forming. It is also known as lost west casting, lost wax casting. Okay, so wax is lost actually in this process. That's why it's called. Sorry, my throat is not good. So lost Wax casting. So, investment casting is a technique used for manufacturing small, accurate castings of refractory alloys using mold formed around a pattern of wax, which is further removed by melting. It is a manufacturing process in which a wax pattern is used to shape a disposable ceramic mold. A wax pattern is made in precise shape of item to be cast. The pattern is coated with a refractory ceramic material. The investment casting process involves steps, namely making a wax pattern that is expandable, investing or encasing the pattern in a suitable refractive material that will stand high heat and reproduce every detail of pattern in the form of mold, and burning out the pattern, leaving a negative mold inside the investment material, and casting by filling the mold with the metal and recovering the casting by destroying the mold. And then permanent mold casting. So these permanent molds are used here, and this is the typical permanent mold casting. And this is pressure die casting. You can go through these details. So in the pressure die casting, actually we have a very good surface finish. So here actually you see pressure die casting, it has the lowest surface roughness, but high surface finish. Okay. And this is a typical sand casting. So sand casting is also known as sand mold casting. It is a metal casting process characterized by using sand as mold material. Question number 18. In a Germany and quench test of heat to plain carbon steel, which of the following represents the sequence of microstructures observed from quench end to the specimen? So the correct answer is the quench end will be having very high or rapid cooling. So uh, martensite, then further martensite plus perlite, then further fine perlite, and then coarse perlite. So the Germany hand quench test is used to measure the hardenability of the steel, which is a measure of the capacity of the steel to harden in depth under a given set of conditions. Germany test provides a measure of ability of a steel to harden by transforming into martensite under set conditions. That is a measure of hardenability of the steel, and a standardized bar that is 25.4 millimeter diameter and 102 millimeter long is heated to austenitating temperature and then placed on a rig in which one end of the steel rod is quenched by standard jet of water, and this results in progressive decrease in rate of cooling along the bar from a quenched end, and the depth from the quenched end over which the martensite is obtained is the measure of hardenability. This is the typical setup for Germany and quench, and this is the steel bar, and then we can quench it in the water, and this hardness versus distance is there. Question number 19. So a long oil pipeline made of steel is suspected to have developed a scale on the inner surface due to corrosion. Which of the following non-destructive technique is most suitable for detecting and quantifying such defects? So the correct answer is option C, ultrasonic inspection. So ultrasonic testing is a family of NDT testing based on the propagation of ultrasonic waves in the object and material. Test is most common ultrasonic testing applications. Very short ultrasonic pulse wave with center frequencies ranging from 0 0.1 to 15 megahertz and occasionally up to 50 megahertz are transmitted into materials to detect internal flaws or to characterize materials. So, and you can go through other methods also. I'm not going into detail. And, question number 20, 20. A steel is plastically worked in a temperature range below nose of TTT curve and above MS, followed by quenching to produce fine martensite. What is the process called? So the process is called Osh tempering. So Mar tempering is also known as stepped quenching or interrupted quenching. In this process, steel is heated above the above upper critical point above transformation range and then quenched in a salt, oil, or lead bath kept at a temperature of 150 to 300 degrees centigrade. The workpiece is held at this temperature above martensite start MS point until temperature becomes uniform throughout the cross section of the workpiece. After that, it is cooled in air or oil to room temperature. The steel is then tempered. In this process, austenite is transformed to martensite by step quenching at a rate fast enough to avoid formation of ferrite, perlite, and martensite. So this is the typical process for Mar tempering. Actually, we have made this transformation at about ms, and then we have transformed it, and then we have tempered it if desired. Okay, so this is the typical Mar tempering process. So in Mar tempering process, austenite metal part is immersed in a bath at a temperature just above the martensite start temperature, and by using interrupted quenching and cooling is stopped at a point above martensite transformation region to ensure sufficient time for the center to cool to same temperature as the surface. The metal part is then removed from bath and cooled in air to room temperature to permit austenite to transform to martensite. And Mar tempering is a method by which the stresses and strains generated during quenching of a steel component can be controlled. In Mar tempering, steel is heated to above critical range to make it all austenite. Was forming. So was forming operation is this at 900 degrees centigrade we do heat treatment. So was farming is also known as low and high temperature thermomechanical treatment is a method used to increase the hardness and toughness of an alloy by simultaneously tempering, rapid cooling, deforming, quenching to change its shape and define the microstructure. This treatment is important part of processing of steels. So here at at 300 degrees centigrade, we are deforming like 10%, 20%, 30% for about 90 minutes, and then cooling again to room temperature. And this can be at very well various temperatures, like it could be like 300 or 350 or 400. So this is a typical intermediate deformation step that is required in us forming. Now intercritical so in the question actually is written intercritical forming. There is no term like intercritical forming, but we have intercritical annealing. So this is the typical process for intercritical annealing. Intercritical annealing involve heating to and holding at a temperature between AC1 and AC3 temperatures to obtain partial austenization, and this is followed by slow cooling or holding at a temperature below the critical temperature and leading to final microstructure of spheroidal carbides distributed evenly in a ferrite matrix. The term C, why it is called AC1, not A1. So AC1 is just a few degree above ideal A1 temperature, and C is from French word chauffage. Chauffage means heating. Okay, chauffage, heating. Now normalizing. So normalizing, this is the normalizing range. This is AC3 and this is ACM. So above AC3 and ACM. This so AC already so far is there. So this is A3 and this is ACM, and so this is AC3 and ACCM. Okay, so just above this line, this temperature range. So normalizing is the process of heating a material to a temperature above a critical limit and then cooling in open air. Normalizing heat treatment is a heat treatment process used to provide uniformity in grain size and microstructure in some steel grades, and normalizing can also be used for cast irons to produce more uniformity, improved wear resistance, and increased hardness values. Normalized heat treatment establishes a more uniform carbide size and distribution, which facilitates later heat treatment operations and produce a more uniform final product. Now question number 21. So this is typical. uh, what is the requirement for equilibrium at a triple junction as shown in figure with gamma 1 2 gamma 2 3 gamma 1 3 as grain boundaries, tension theta 1 theta 2 theta 3 are dihedral angles. So as you have seen the Lami's theorem, so gamma 2 3 divided by sine theta 1 is equal to gamma 1 2 divided by sine theta 3 is equal to gamma 1 3 divided by sine theta 2. So correct option is B option. Question number 22. In a in the A-rich end of AV binary eutectic phase diagram, the solidus and liquidus are straight lines. So this is the this is solid, this is liquid, this is solid plus liquid, and these are the straight lines. Okay, so we extended this and this in red. Okay, so at 16, this is the freezing range. So we take the similar triangles, this one and this one. So this is freezing range divided by this 660 minus 460. This length is 660 minus 460 is equal to this distance. This is 32 minus 16 divided by 32 minus 0. So freezing range comes out to be 100 degrees centigrade. Question number 23. A vector field is given as f is equal to minus x square y plus xy square ik plus x square y j cap. The divergence of the field evaluated at x comma y is equal to 2 comma 2 is. So divergence of f is del f1 upon del x plus del f2 upon del y plus del f3 upon del z. So divergence of f will be equal to this minus 2xy plus y square plus x square. This will be equal to 3 sorry this just a second. So this is x square plus 2xy plus y square, and this is equal to x minus y whole square, and this will be equal to 2 minus 2 square is equal to 0. So the correct answer is 0. Question number 24. A plate of thickness h is equal to 120 mm is cold rolled in a mill with roll diameter of 200 mm. If the coefficient of friction mu is equal to 0.1, the maximum possible reduction delta H is in a single pass is H is equal to 120 mm, roll diameter is 200 mm, roll radius is 100 mm, mu is equal to 10 theta, and delta H is equal to mu square R. This will be equal to 0.1 square into 100 is equal to 1 mm, where delta H is the maximum possible reduction. Okay, so delta is H here is 1 mm. Question number 25. A copper aluminium diffusion couple develops a certain concentration profile after an isothermal treatment at 600 degrees centigrade for 10 hours, and the time required to achieve same concentration profile at 500 degrees centigrade is. Interdiffusion coefficient for copper in aluminum at 500 degrees centigrade and 600 degrees centigrade are 4 into 10 to the minus 14 meters square per second and 8 into 10 to the minus 13 meters square per second. So for interdiffusion, fixed second law, by solving fixed second law, we get Cx comma t is equal to C1 plus C2 divided by 2 minus C1 plus C2 divided by 2 error function x upon 2 under root dt. For concentration profile to be same, x upon 2 under root dt should be same. That means or under root dt should be same for 500 degree centigrade and 600 degree centigrade. That means under root d1 t1 is equal to under root d2 t2. So on solving this, we get t2 upon t1 is equal to d1 upon d2 is equal to t2 upon 10 is equal to 8 into 10 to the minus 13 upon 4 into 10 to the minus 14. So t2 comes out to be 200 hours. So thank you for your attention.